Okay, so in this video, we're going to talk about graphing rational functions, and we're going to start with some easier ones, or maybe some smaller ones. I don't know if easier is the word. We'll do a few different examples, and I'll do them in different videos so you can kind of just watch one and then go back and look at what you need to do or whatever. So that it's not a 45-minute explanation. Okay, so we're just going to pick one, and we're going to go through graphing it. And for rational functions, it's always the same. We're going to be doing the same stuff each time, but I'm going to show you what we're going to be looking at here. Okay, so there's a couple things that we're going to be doing, and we'll start with like I said, a simpler one, and we'll work our way up to a bigger one. So let's start with this rational function. Okay, and how do I know it's a rational function? It's a fraction where there's a variable in the denominator, and that's basically what makes it a rational function. Okay, we looked at the parent graph of rational functions in one of the other videos in the vertical asymptotes and the horizontal asymptotes. So we know that the parent function is this one, and he looks like something that looks like this. So since it's a family of functions, they're all going to have some similarities to this one. But rational functions, unlike some of our other functions, their families actually usually look more different. You know, like parabolas all look like parabolas. Quadratics, they all look like parabolas. Parabolas all look very, very similar. These will actually look a little bit different depending on how this looks, okay? But there will be asymptotes, and there will be, curves and different things, okay? For the most part. So let's take a look at this. If we're going to graph a rational function, we're going to do all the things that we would normally look for in a function to be able to graph it. So I'm going to look for intercepts. I'm going to look for vertical asymptotes. I'm going to look for horizontal asymptotes. I'm going to abbreviate this VA and HA just to make my life easier. And I guess that's basically what we're going to look for. We're going to look for additional points if we need to. And later on, when we talk about it more, we're actually going to be looking for holes. This one doesn't have a hole, so we'll put this one on hold for right now, and we'll talk about holes maybe a little bit later. Okay, so let's take a look at this guy. If I'm trying to find x-intercepts, which usually we want to find x-intercepts when we're graphing something. How do you find x-intercepts? You let y equal 0, right? That's true for lines, it's true for parabolas, it's true for any function. In order to find x-intercepts, you're going to find where the y is equal to 0. So that's what I'm going to do first. I'm going to try to figure out where y is equal to 0. Now remember, a fraction is equal to 0 when the top is equal to 0, but not the bottom. So what does that mean? In this case, we want this piece, the numerator, to be 0, but the denominator to not be 0. So if they both are 0, then it's not an x-intercept, or the fraction is not equal to 0. It's undefined. So what am I talking about? If I had this, -3 would make this bottom equal to 0, and it makes the top equal to 0, so we feel like it should be, the fraction would be equal to 0, but because it makes the denominator 0, it doesn't actually make the fraction equal to 0, it makes it undefined. So that's what I mean by the bottom cannot be 0 at the same time. Do you see how -3 would make both the top and the bottom 0? So I'm just going to cross that out because I know people look back and they're like, where did that come from? So that was just a little example of what I mean here. The top and the bottom can't be 0 at the same time. But the same number is not going to make both the top and the bottom 0 here. So what we're going to do is we're really just going to set the top equal to 0, because I really want to know when is the top going to be 0. And the top's going to be 0 when x is equal to -3. So this one is going to be my x-intercept, because again, it makes the top equal to 0, but not the bottom. It makes y equal to 0, and y is the value of this fraction. We got it? Now y-intercepts, what do? I let x equal to 0, okay? So let's take a look at this one. I'm just going to plug in a 0 for x into this one. So I get 0 plus 3 over 0 minus 4. So my x-intercept is y is equal to -3/4. And again, you can write it as a ordered pair if that makes you happier, but you don't have to. If you're saying that it's the intercept, then it's implying that the other one is 0. So I'm okay with this. I usually just leave them right. I usually write them this way. But if they ask for the coordinate or whatever, that you know that the other one is 0. Right? You just made it 0. So okay. So those are my intercepts. I did number 1. Done. The next thing I'm going to do is my vertical asymptotes. Now the cool thing is vertical asymptotes are kind of like finding x-intercepts, but you're doing it with the bottom, right? You're just trying to find out what makes this bottom piece equal to 0. So for my vertical asymptotes happen, we want the bottom to be equal to 0, but not the top. So we already said that the same number will not make the bottom and the top equal to 0 at the same time. So really all I'm going to do here is set the bottom equal to 0. And this is my vertical asymptote. And it's actually this equation. You have to say x is equal to. X is equal to 4 because it's a vertical line. And that's the equation of a vertical line. It's not the number 4. It's x is equal to 4. It's that equation. So the equation. Asymptotes are always equations. Okay, so asymptotes are always equations. They're not numbers. All right, now my horizontal asymptote, if you remember, we're trying to see kind of what happens when x gets really big in this fraction. Like infinity big, right? Not just big, but infinity big. So again, this is my guy or gal, I don't know. Here it is. I'm going to put infinity in for x. So I'm going to let x be really, really huge. If it makes you feel better, you can, use a different symbol than infinity. And then what do? Remember, these guys in the back kind of don't matter. They're basically worthless. Why? Because if we have infinity plus 3, well, nobody says I have an infinity plus 3. That's the same thing as saying I have infinity. If you had $10 million, $10 million and $3, you wouldn't say I have $10 million and $3. You'd say, oh, he has $10 million. It's that same idea. These are too small that we don't even consider them part of the number. So if you had 10 million and 3 over 10 million and 4, think about it that way. What number is that close to? It's close to 1, right? So this guy is close to infinity over infinity, which reduces to, it's approximately 1. So our horizontal asymptote is y is equal to 1. That's my horizontal asymptote. Okay? All right, now I'm going to take all of this information to try to graph my graph. So I'll zoom out a little bit. I know it'll make it harder to see. I'm sorry, but I don't know what else to do here to try to, here's what we'll do. We'll just zoom into here because here's my function right here. Do you see him? He's right here. This is the guy I'm going to sketch. Okay, so let's sketch him right over here using this information. So the first thing I'm going to do is draw in my x intercept, which is here at 1, 2, -3. Then I'm going to do my y-intercept, which is down here. If this is -1, he's like here, -3/4. Okay, so my x and y-intercepts, I just drew those in. The next thing I'm going to draw in is my vertical asymptote. It's this line, x is equal to 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, there's my vertical asymptote. It's the line x is equal to 4. My horizontal asymptote is y is equal to 1. So I'm going to draw in that line y is equal to 1, which is, of course, a horizontal line. And that's why we call it a horizontal asymptote. Okay, and now remember, because it's an asymptote, because these are asymptotes, right? Horizontal asymptotes means as x gets really big, y has to get close to the number. And vertical asymptotes, as y gets really big, x has to get close to the number. So we already have some clues as to what's going to happen here. Now, I feel like, since this is my vertical asymptote here, and I see that I have 2 points here, and somehow I have to get close to this vertical asymptote, I know, well, even think about it. Here, let's think about it for a second. If I put in numbers close to 4, but on this side of 4, on this side of 4, so like over here, just think about it for a second. You don't even have to, imagine. You can kind of reason it out. Think about if I put like a negative 3.9 in there. I mean, a positive 3.9, because we're talking about on this side of 4. And a positive 3.9 on top. I'm going to have a positive number on top, a positive 6.9, and on the bottom I'm going to have a negative 0.1, right? So that number is a big negative, right? And it's going to get to be a bigger and bigger negative. So what's going to happen is it's going to start to go down like this on this side. It's going to start to get close to this asymptote and go down like that. And over here, what's going to happen with this asymptote, think about if I put like really, really small numbers in here for x. So if I put like a negative 1,000 plus 3 and a negative 1,000 minus 4, what's going to happen, that's going to give me a positive number, isn't it? It's going to give me a positive number close to 1. So what's going to happen is I'm going to get closer to this asymptote. And so I think that this is what my first part of the graph is going to look like. Now this vertical asymptote has broken this graph into 2 pieces. There's here and there's here, because we're going to use every other x besides 4. So that means I've used all of these values to the left of 4, which means there has to be something here over to the right of 4. And really what I have to decide is it going to be a curve that comes down here, or is it going to be a curve that comes up here? Those are really my 2 choices. Now, I feel like I already know the answer to that. And not because of this picture, because remember how I said the parent graph, sometimes you can have a graph that looks like that, and sometimes you can have a graph that looks like that, or sometimes you can have one that looks like that. These functions kind of move around. So this is what I meant by sometimes the rational functions don't look quite like their parents. But I think I already know where it's going to be, and I'll tell you why, and then I'll show you how to figure it out even if you didn't catch this. We said that the x-intercept was negative 3. That was the only place this fraction will be a 0, right? Which means this has only one x-intercept. Well, think about it. If I try to draw a curve that comes in here, what happened? Didn't I cross the x-axis, which would mean it had 2 x-intercepts? Sure. So that means that I don't think my little curve is going to be down here. I think my curve is going to be here. But how can I know for sure? Well, here's what I'm going to do. I'm going to pick a number. This is 1, 2, 3, 4. So I'm going to pick a number over here like 5. And I'm going to plug it into my original function. So my original function was this one. And so we get x is equal to 5 plus 3 over 5 minus 4. And what number does that come out to be? It comes out to be 8 over, is that 1? So is that number bigger or smaller than this horizontal asymptote? What was this horizontal asymptote again? It's y is equal to 1. So when I get a 5, I'm going to get a number way up here at like 8, right? So I feel pretty confident that my second curve is going to be up here for those 2 reasons. Because when I pick a number on this side, it comes out way up here, it comes above the asymptote. And also, I know it can't be this one because that would mean I'd have to go through the x-axis again. And it doesn't, because we only had one x-intercept. And so I feel pretty confident this is my picture. And again, it's possible to go below the asymptote. That's a possibility. It could actually do that. But I feel pretty confident it's not. And I'll show you how to just check to make sure. Okay? So now what I'm going to do is I'm actually going to look at this picture on my calculator. And don't look at the picture until you've tried it, because that's cheating. You want to try to draw it without looking at it. So I'm going to do x plus 3 divided by x minus 4. Because once you see it, it's ruined, right? You can't pretend you don't know what it looks like once you've seen it. So try to draw it first, and then you can look at the calculator. If you look at it first, it's cheating, and you should feel very guilty about that. Okay? So here I am. I'm going to graph this. I'm just going to hit zoom standard because sometimes I don't know what this calculator is set to. And you can see there's my first curve, and there's my second curve. And this one is not drawing in the vertical asymptote, but the vertical asymptote is here. And you can see this comes above the 0. Maybe you can't see it, but it does. It comes above the 0, so you can kind of see that it comes above. And this one is not looking like it's getting down to 0. It's only getting down to 1. Now, like I said, I kept my little curve. It could have actually come underneath the asymptote and like approached from below. So this is a possible thing that could have happened. I could have had a graph that if this is my asymptote, I could have it do this and like approach the asymptote from underneath. Or like on this side, it could have gone this way and gone over and approached from the top. That's a possible thing that could happen. Now, do I feel like this happened in this one? No. But how do I check? Well, I can put a really big and a really small number in and check. So if I go to my table, and I have my table set to be able to type in the x's that I want, I'm going to put in a really small number, meaning a big, big negative. So I'm going to put in negative, whatever, a really big one. And it comes out to be 0.9999. So out here at negative, whatever I typed in there, it's still less than 1. It's still below this asymptote. You see what I did there? And then on this side, what am I going to do? I'm going to put in a really big number, like one with lots of zeros after it. And let me do a little bit less, because remember I said sometimes the calculator, it gets so close to it, can't tell the difference. You can see that it's still at 1,000. It's still above the 1. I feel like it's not going to go down. And the other way that you can do it algebraically is you can see if this fraction ever can be 1. So how do I know if this is going to cross this line or not? Well, I'm going to see if this fraction ever has a value of 1. You ready? Let's take a look. Because in order, see how this graph gets close to 1 here and close to 1 here, but it doesn't touch the 1? How do I know that it's never going to touch the 1? Well, just take a look at this guy. Let's say that this is equal to 1. We want the y's to come out to be equal to 1 for it to cross the asymptote. When I multiply both sides by x minus 4, I get minus x, I get negative 4 is equal to 3. When is that true? Never. Which means this graph will never be here, which means if it's below here, it can't go over it. And if it's above here, it can't go below it. So this little algebra here just proved that I can never cross this particular horizontal asymptote. Sometimes you can cross horizontal asymptotes, but in this one, we will not. Okay, so I know that was a lot to take in one video, but the good news is it's a video, so you can kind of go back and watch it again, the parts that you felt confused about. And I will be posting more of these videos of graphing these as we go through the week. So be on the lookout for them. I know you're holding your breath to see the next one. Don't worry, it's on its way.